right, if I'm going to graph out this relation to determine if this is a function, first ordered pair that's given, 4, -2. So reviewing just simply how to plot points along the x-axis here, I go out to where, x is 4. And for the y-axis, I go to where it's -2, plot a point. Second point is 3, 9. So on the x-axis, go to where x is 3. The y-axis, line up where y is 9, plot a point. Got -3, 9. So let's see, x is -3, y is 9. 0, 6. All right, 0, 6 is going to be on the y-axis because we're not moving left or right for the x values. We're staying at home at 0. We're going up 1, 2, 3, 4, 5, 6. This would be a y-intercept type point. And then let's see here. We'll use orange. -5, 0. On the x-axis, I go out 1, 2, 3, 4, 5 to the left for the -5 value. We're staying at home for the y's because y is 0. I'm plotting a point. Nice and colorful. Now, if we're trying to determine if this relation is a function based on the graph, we're going to go back to what I was talking about earlier with that vertical line test. Vertical line test, essentially what you're doing is you're taking a vertical line and you're dragging it across the graph from left to right. Best way to do it. As long as that line goes through at just one point for every point you encounter, you have a function. Now we've got 5 points to consider here. If I drug my vertical line through this first point, it would just go through that one point. Through the second point, same thing. Third, just going through one. Fourth, just going through one. Fifth, same thing. So is this a function? Yes, it is a function. It passes the vertical line test. We'll plot the points for this relation, starting with 1, 1. X is 1, y is 1. Plot your point. 2, 2. X is 2, y is 2. Plot your point. 3, 3. Out 3, up 3. Got this line forming right now. 1, -1. All right, where x is 1, y is -1. I plot a point. And then 4, -1. X is 4, y is -1. So I've got all my points plotted for this relation. If I start to do that vertical line test, as I pass through each point, I got to make sure that I'm only going through one point, and as we can see right away, the first points we encounter, we're going through 2. Can't happen. Can only go through 1 all the way through for all the points that we're testing. So this would not be a function. So being asked to plot some points over a given domain, I have to recall that domain has to do with all the x values, right? All the possible x values. So if I could set up a little xy chart here to plot my points, I know that the x values would be -3, -2, -1, 0, 1, and 2 for all of these. And if I know that, all I have to do here is take these x values and plug into the given equation up here. Now, wherever I see an x, I'm going to insert these values. Here, I only see the one x. So if I plug in -3 for this x, I'd be taking the absolute value of -3 minus 4, which is 3 minus 4, giving me a y value of -1 back. So as an ordered pair, I'd have a point of -3, -1, that I could plot. I know that point would be on this graph. I take -2, I plug in for my x up here. I have the absolute value of -2 minus 4, which would be 2 minus 4, or -2. So a second point I could plot. negative 2, negative 2. And you can plot these points as you go. You take negative 1 and plug in. Negative 1 goes in. Don't have to write out the steps, right? If you know what you're doing with the calculation, it would be 1 minus 4 once you take the absolute value, so negative 3 would be back. If you plug in 0 for x, that'd be 0 minus 4, so negative 4. And then if you plug in 1 and you plug in 2, you're going to get the same kind of results back as you did for negative 1 and negative 2, right? So for 1, I'd get negative 3. For 2, I'd get negative 2. And again, I'm getting ordered pairs for each of these as I plug in. So I take this chart, I get my ordered pairs, I plot my points. That basically takes care of the directions here. If I want to take this a step further, though, once I graph everything out, I could decide whether or not this is a function. So just for fun, let's see if we can decide if this is a function. Now, I'm not going to plot any points. I'm just going to use what I know about the definition. You want to take a guess as to whether or not this is a function? It is. Okay, based on the definition, for each x value basically we're plugging in, we can only get one y value back. So every x here is matched with exactly one y. Since that's consistent all the way through, this is a function. So to appreciate the big picture here, that's just nice to know. All right, as much fun as that was to do that all by hand, if you'd like to enter this into your calculator, what you could do, after you turn on the calculator, go to the y equals screen. On the y equals screen, you can type in your equation, assuming the equation is solved for y. You know, if not, you could try to solve it for y. If it doesn't seem reasonable to solve it for y, then just do it by hand. But for some of these, they're set up all ready to go. Y equals, in this case, absolute value of x minus 4. What you can do to call up the absolute value on your calculator, you can go to this math key down here on the left side. If you scroll to the right along the top, where it's the number option, there's your absolute value right there. Now this can vary from calculator to calculator, but this is pretty consistent on the TI-83 and the TI-84, okay? So I want to call up the absolute value. I hit enter. It enters it in for me back here on the y equals screen. I'm taking the absolute value of x. So if I hit x and close the parentheses, on the 83 model, that's the absolute value of x. Now if you're using the 84, chances are you've got little absolute value bars sitting there, and you can just put x in between. That varies just a little bit, but it's the same idea. We're going to subtract 4. And now I have entered in my equation. If I want to cheat a little bit with these tables, right after all, this table is just an XY chart. If you hit second and you hit window, that takes you to the table setup. Under table setup, what you want to make sure you have as an ask option is the independent variable. So chances are, if you haven't done this before, it's probably on auto. You want to change it to ask. So put it on ask, hit enter. All right, so where were we? We put this on ask. Once we put this on ask, now you hit second and you hit graph, which takes you to your table. Now depending on when you've used this option before, how your table looks compared to mine up here might differ. But just understand that however it looks, you can go ahead and start entering in x values right now. Like if I want to enter in all these x values over here, negative 3, negative 2, negative 1, I just type negative 3, enter, and it goes in. Negative 2, enter, and it goes in, and so on down the line. And voila, there are your corresponding y values. So you can take those and plot those. All right, we'll play with this equation here just basically because it's got a few more x's for us to use. If we approach this the same way we did the last problem, we set up an xy chart. We're working over the domain of integers from negative 3 up to 2. We're plugging these x values into our given equation up here by hand if I plug it in to figure out this first y value. Negative 3 goes in for that first x, and I have to understand that that first x is squared. So negative 3 gets squared. I subtract 3 times the next x of negative 3. And I could see on this one where maybe order of operations we could screw up, or the sign right here on the squared part we could screw up, so be careful. If you calculate this out, you've got what? You've got 9 here, negative times negative, positive 9 here, so that'd be 18. You've got an ordered pair of negative 3 and 18 that you could plot. So just as the case was with the previous problem, we continue down the line here, plugging in our x values as we go. Negative 2 goes in, we square that, minus 3 times negative 2. So that's going to be positive 4, negative times negative, that'd be plus 6, so that'd be 10. Got an ordered pair of negative 2, 10. And you can continue to do this by hand, but like I showed you with the calculator, if you want to play with it, especially now that we've got this table set up and we've already got our domain of values in there, go to your y equals screen again. Clear out what you have there and enter in the new equation. Since this is solved for y, x squared, so you can do the caret key with the 2, or you can just use the squared key down the left-hand side, minus 3x. Again on the table, all those x values we just used should still be there. If you go back to the table, second graph, hey, look at that. We got all the numbers we need. So this is nice because this equation is solved for y, but also if you had any concerns about how you were squaring that value, are your signs correct, you could check it off this. So I take these values, I put them in, I've got 4, I've got 0, I've got negative 2, I've got negative 2. I've got all the points that I need to plot. And like we did as the special added bonus on the previous problem, we discussed whether or not we had a function we were playing with. Is this a function? It is a function because for every x value we insert, we get one y value back. Exactly 1. So it's a function. Now, as long as the equation is solved for y, using the calculator can be an option. All right, if these problems have not caught our interest yet, this one should. How we set this up? Well, set it up the same way as the previous ones. Get your XY chart going. This one is not solved for y, so the calculator is not as convenient, but we still know what x values we're plugging in. We can go ahead and plug those in and then just kind of see what happens as we get our y value back. So start with the negative 3. Do a little scratch work off to the side. I know negative 3 is going in for x up here. If I plug that in, it's the absolute value of negative 3 plus the absolute value of y equals 7. The absolute value of negative 3, of course, is 3. And if I'm solving for, well, at least as much of y right now as I can, I would subtract that 3 over. I'd have the absolute value of y equals 7 minus 3, so 4. Now I want to figure out what y is going to be when x is negative 3. What is y going to be? Any ideas? There we go. As long as you remember your definition with absolute values, we know that the absolute value of y, if it equals 4, would have to be either 4 itself or negative 4. You get 2 values back here. So you get 2 ordered pairs. You get negative 3 and 4, as well as negative 3 and negative 4, which if we're trying to decide if this is a function, is this going to be a function? No, because we're getting 2 values back as opposed to just 1 for the x value we plugged in. This is not a function. So we continue with that process down the line. If I take -2 now and I plug in, do a little scratch work off the side, absolute value of -2 plus absolute value of y equals 7. Absolute value of -2 is 2. Subtract 2 over, you've got absolute value of y equals 5. So if absolute value of y equals 5, y would be 5 or -5. And if you continue in the same manner and you start to see the pattern that unfolds, plug -1 in. If you plug -1 in, you should get 6 and -6. If you plug 0 in, that x term drops out, and you've got the absolute value of y equals 7, right? So that would be 7 or -7. And then when you get down here to 1 and to 2, well, same kind of results are going to happen as what you got for -1 and -2. So for 1, we got 6 and -6 because that's what we got for -1, and for 2, we get 5 and -5 because that's what we got for -2. So we get 2 points to plot for each x. That's why we don't have a function that we're playing with.